My name is Judah Wood, and this is my submission to the Design Innovation Scholarship. All right, let's get straight into it. I'm going to walk you through the 5 steps of the design process, the same process I used to design this robot. Step 1, Create CAD! This is our fast idea phase in CAD, where we quickly model mechanisms like intakes, elevators, or manipulators, which we piece together to make as many robot archetypes as we can. Then create a pros and cons catalog that gradually narrows our options until we arrive to the robot we want. Our final current CAD robot featured a 360-degree arm, a ground intake for coral, and a dual-purpose claw for algae. Step 2, Master Sketch. This is where the math solves the early problems, letting us prove ideas through robot concepts. All focused on dialing in compressions, defining framing, and calculating belt lengths and gear ratios. Our Master Sketch helped us lock in the arm pivot, refine the coral compression, set the intake pivot for a smooth handoff to the arm, and determine the elevator stages needed to reach our height goal. Step 3, Block CAD. After we've proven our core concepts, this is where the design really starts to take shape. This is the phase in the robot design process where you take your master sketch and build off of it using basic geometry and your understanding of complex robot designs. You're blocking out mechanisms and making sure everything works together mechanically. This is just an example, but overall, here it becomes a fast placeholding system that lets us test ideas, more pivots, and adjust layouts without fully detailing everything. The key difference from normal CAD is speed. We define problems early on and solve them immediately. This is just a high-level overview of this phase. I'll dive deeper into specific design decisions and why we made them in the next couple of steps. Step 4 and 5, Robot CAD to Real Robot. Every robot CAD starts in the part studio. We import our block CAD and start building directly off of it, creating plates, shafts, tubes, and any 3D prints. Next, we fully construct the components into CAD into 2 assemblies, the static assembly and the active assembly. Then you put them together to make a subsystem. This subsystem is the intake, and let me dive a little bit deeper. Here's our intake. At the core, we're running a high gear reduction into a custom 10 DP tooth gear plate that drives this system. We also carry a high reduction into our intake rollers, which allows us to use a smaller Kraken 44 while still driving consistent torque and controlled pickup. Next is our robot arm, designed with a full 360-degree range of motion. At its core, it runs a high gear reduction with a motor packaged inside the arm tube. All of this is driven by a custom 10 DP tooth gear plate, rotated by a very high gear ratio paired with a Kraken 60. We also have an absolute encoder on a 1-to-1 pulley ratio that guarantees we know the exact arm position at all times. We also have a slip ring which allows continuous rotation without hesitation. That's hooked up to our claw motor. This was definitely the hardest subsystem to get right and the most rewarding to solve. It sharpened my approach to design, and with that, I moved on to the next design. The elevator. We chose a 2-stage continuous rope-driven elevator to maintain consistent tension and achieve consistent controlled vertical travel. A rotating tube at the base actively removes slack, pulling the final stage upward for a smooth controlled extension. By integrating hard stops directly into the pulleys, we keep the system compact, and the rope runs along the bottom and the top of each stage. There are also dual ratcheting tensioners and a spring maintaining consistent tension and eliminating slack throughout travel. All of this came together to make this robot, and in the end, I chose to highlight the 5 steps, not just because they build a robot, but because they build alignment. The process creates more teamwork, and more teamwork creates stronger collaboration. It creates clarity. With clear steps, everyone, no matter their experience level, knows where they fit in. New members can jump in and contribute, and veterans can push their ideas further. The structure gives everyone ownership of the outcome. Each step connects people the same way it connects mechanisms. Ideas become sketches, sketches become geometry, geometry becomes structure, structure becomes motion. But none of it matters until it all works together. The robot isn't just parts sitting next to each other, it's ideas layered on top of each other. It's feedback, it's compromise, it's refinement. The more structured our process became, the more connected our team became. And when everything finally moved as one, that's when engineering became visible. Because collaboration is what turns ideas into reality. And in the end, integration wasn't just mechanical. Somewhere along the process, I became integrated too. And I realized it was never about me building the robot. It was about the people around me building me. Hi, my name is Judah Wood, and this is my submission to the Design Innovation Scholarship. Thank you for watching.